Hello everyone, my name is Sakshi Deshmukh, a student of Praxis Tech School, enrolled under the course of Data Science, Machine Learning and AI. Here I am to talk about Foundation of Machine Learning. Now, when we talk about machine learning, it is basically a branch of artificial intelligence. So, where instead of programming a computer like step by step rules and give it examples, the computer then learns from those examples and then uses them to make prediction or decisions. Let's think of it like teaching a child. We don't have to explain like every rule to them. We just have to give them example and then they learn, right? So ML works in the same way. It learns from the data and not from the strict instructions. So if we talk about why machine learning is so big nowadays, so first of all, it is because there's a explosion of data right now. Like every second, people are generating tons of data through social media, online shopping, apps, and whatever. And secondly, we have like now powerful computer and cloud system that can handle huge data sets quickly. So basically we have to now like we have advanced algorithm and mathematics also, which allows the computer to recognize complex patterns. So now if we talk about programmed approach and machine learning approach, there are two ways, right? So programmed approach is basically the old way, whereas ML approach is the new way. So if we compare between programmed approach and machine learning approach, in traditional programming, the computer solves the program using specific coded rules. It works, but again the adaptability is very low. And as we know that there are number of like if we are using a programmed approach, then for suppose if we take example of cat and other animal, so if we want the computer to predict whether the picture that we have shown is a cat or not, we have to write specific lines of code that if it has whiskers if it is a cat, if it has pointy ears if it is a cat, if it has a small triangular nose then it is a cat, like that. So the number of codes increases, so the complexity also to read all of those lines also like increases basically. So the rules also not the rule, the code also become nearly impossible to manage, like that. Whereas in if we talk about machine learning, so there, as I said earlier, it basically learns from the data that is being provided. Also it quickly adapts, like if we change the data, it will learn according to the new photo that we have provided or the new data that we have provided. Also since it learns by itself, so it is not that complex. Also now when we talk about core idea, so in programmed approach we have to tell the computer like in multiple lines of code the specification, basically like I said in the cat and other animal example, we have to specifically code all of the specifications that the cat has for it to predict whether it is a cat or not. Whereas in machine learning, we just have to put in the photos of cat and other animals as well, and it will automatically predict whether the new photo that we provide is a cat or does it belong to other animal. Now when we talk about approach, here machine learning, it is a probabilistic approach because even if we provide multiple of um photos of cats, right? There are multiple breeds also. So there, so if we provide a new data and it has some similar features, so it may predict it as, like, if we put in a photo of a dog with pointy ears and like that. So now, since the ML model has learned that if the uh, animal has pointy ears, then it should be considered as a cat. So uh, with with the new photo of the dog with pointy ears that we have put, it the ML model may predict it as a cat, which is not true, right? So it is like there are some chances of error as well. So that is why we call it as probabilistic approach. Whereas in programmed approach, we have to specifically write every line, right? So we can make exception as well in that. So it can be said that it is a deterministic approach. Now, if we go into the example of like weather, suppose if we imagine we have a clever computer friend who is very fascinated by weather but doesn't quite understand it yet. So our goal is to teach uh, teach whether it is a sunny day or a cloudy day. So according to it, what we can do is, first we have to give the computer many weather reports, some labeled as sunny day, others as cloudy day, with details like cloud cover, temperature, wind, and etc. So this will be the computer's data. Now, when we talk about patterns, now what the computer will do is it will analyze the report and then find patterns. Uh, so it figures out what condition consistently lead to a sunny day, that is clear sky, low clouds, and like that, and whether if it is a cloudy day, like high clouds, uh, high cloud coverage, like that. So it basically predicts on its own, like learns on its own, right? So now when we give new weather conditions, then the computer uses the learned lines, or the learned, what to say, pointers, and then it makes a smart guess and tells us whether it is a sunny day or a cloudy day. So as we can see, we can see the table where it has, like, it is a very basic example. Like there are 5 columns, right? Now there's clear, if the cloud coverage is between 0 to 10, precipitation is none, wind speed is between 5 to 15 range, then it can be considered as a sunny day and clear sky, basically, right? Otherwise it will be a cloudy day. So that's what this example was about. Now let's move into how an ML model is deployed. Now if we talk about this, how an ML model is deployed, the first and foremost point that comes is the problem statement or the business understanding. So now what we want is a problem that we need to solve, basically an opportunity that presents itself, that okay, this is the thing, and we have to make sure that this thing is solved, this problem is solved, right? So like, why is this problem happening, or what can we do about it, why is it happening, like that. For example, if we take predict loan defaulters and also to reduce risk, it is a good example of problem statement here. So in business understanding, there comes a point success rate criteria, which basically means that whatever model that the company is using right now, if we want to increase the performance, so that should be our main success criteria. Even if it increases by like 50 or 25ish percent, that is also good enough, because it is, again, like greater than what it is doing performing right now, right? So that's what. And there are like two criterias under it. It is data science criteria and it is business criteria. And when we talk about who does all of these things, so it is done by executive users or sponsors. Now we talk about data understanding. Now we have the problem statement. Now what do we have to do is we have to, from all of the data, from all of the thousands and hundreds of data rows, we have to specifically figure out what kind of data do we need to solve this problem. So we need data need. So what would we need is data available and the quality, volume, and how can we access it. This is basically done by data scientist or chief data officer of the particular company. Now there comes data prediction and processing. Now we have the problem statement, we have the data as well. Now what do we have to do is we have to filter out the rows basically that can fully understand or can help to resolve the problem that we have in our hand. It is basically done by data engineer, data scientists, statisticians, and domain expert. Now we have the problem statement, we have the data, we have processed the data as well. Now we will try model building. There are various models that we can try, and accordingly to whatever um, extent of results we want, we can try between all of these models. We'll talk about in the upcoming classes or the upcoming videos. So like that, it is done by data scientists and domain experts. Now we evaluate the model if it is predicting nearly correct or not. If it can, like, obviously it can work best in the train set, but we have to see if it can show us the same result in the test set. There's a measure named as MSE that we learn in the upcoming videos. From there we can actually predict if the MSE of train set or of MSE of the test set is correct or not, if it is predicting right or not, if it has either understood the data as well or not. We'll get to know in the upcoming videos. Yeah, test set performance and train set performance. It is again done by data scientists and domain experts. Now, after all of these things, we have the problem statement. We have we have done the success. We have defined the success criteria. We have also done data processing. We have managed the models as well, and we have tested it on the test set as well. And with all of those things like fully finished, we can finally deploy the model. Now this is the flowchart of how ML model basically is made. Like there's business problem, success criteria, action, decision, and judgment are the things that suppose if we take an example of suppose there is a village where you have to, well, there are artisans who can work, who have the skills and everything, but they want to make it to the, like, they want to sell their products more, right? They want to enter into the market. So this is the problem statement, that they want to enter into the market with their own products that they have made. Success criteria would be one, that their products are being sold with them making additional profits, right? What action can they take is they can make good products. They can list it on a very, like, they can list it on websites. They can predict the trend or whatever the patterns that are right now like currently popular, and according to it they can make their products, and from that it will help us, it will help them basically do like more work, like more designs, and they can architect, then they can basically make according to whatever the trends are. So from that they can predict if this product will go or not, or if this is the trend. So if I make this product, will this still be will this still be used if another trend comes, like that. And accordingly we can deploy the model. Now there are the when we basically understand the data set, we can then make we will be it will be easier for us to um, make the it will be basically easy for us to uh, like first divide into train set and test set, and after that and then basically predict. So for now, what where it is suppose this is the chart. Here it is x1 to xn, and here are different, like here is column x1 to xn. Okay, this is the data that we know. Okay, from x1 to xn, and in column, and then we have x1 to xn in rows as well. Now y is the column where the predicted value will come. So for now, what we'll see is just what this x-axis, what this x columns are called is independent variable, whereas the y column what will be called as dependent variable. Now why x column is called independent variable? Because that is the data, or that is the values that have come, that are free, right? They do not depend on each other. It is the like it is like a value basically, right? It is a normal constant kind ish value. Whereas in the y column, it is something like from these x column we have to predict y, so y will be dependent on the x variable, right? So that's it. Do let me know if you have any doubt. Thank you for watching, and keep learning. Thank you.